Thank you for coming to my presentation. Today, I'd like to have a seminar as a rehearsal of conference, ACE 2011, in next week. But before that, let me introduce myself and my previous research briefly. I'm Kazu, second year PhD student, coming from Osaka. Osaka is the second biggest city in Japan, and I think Osaka is very much more busy and crowded city than Christchurch. But we can get many kinds of nice food like takoyaki and okonomiyaki. If you go there, please try the takoyaki and okonomiyaki. And fortunately, we have almost no damage from the earthquake. Although I was in Tokyo, the damaged area, when earthquake occurred. From 2006 to 2010, I used to be a member of Human Interface Engineering Lab at Osaka University. And from 2010, I moved to the Takemura Lab at the same university. This is the lab of Atsushi Biron, and Rob used to be there in last year.
It's a really fun place.
My research interests are human-computer interaction and virtual reality. And today, what I tell you is about computer-supported corporate work. What I did. So, anchor navigation is an interface to navigate maps. Let me show you the video. In this technique, users can put an anchor point like this, and the anchor point always remains in a viewport by automatically coupling zooming with panning and double tapping to replace the anchor point. This is another technique using tilt of the virtual camera. So this technique allows us to operate the view without mode switching among pan, zoom, and tilt. And it also allows us to maintain a sense of context. This is a newer project, Elastic Scroll and Zoom. This technique is a multi-touch navigation technique where the contents is regarded as a flexible object like pieces of cloth or paper. This is a prototype of the interface. During interaction, the content is shrunk and stretched. This allows us to view both the new and the original area. So it makes it easy to prepare for our next operation. If users only release the fingers, the normal operation is performed. But like this, user flick back the fingers, the view return back to the original view. we submitted this research to the CHI 2012. This is very funny project in the field of virtual reality. The umbrella, the name comes from fan and umbrella. This is an umbrella-like device that makes us experience rain, even inside. So we use the microphone-like mechanism using coil, spring, and magnets. And when raindrops hit the umbrella, entire umbrella is shaking, and electric signal generated. So we record the signal and replay it. So we can reproduce the sensation of rain. So this is a scene of the recording vibration. And when replaying it, the mechanism shakes up and down. So users can feel like this.
Oh.
He's an actor.
The student is just so amazed by it.
This is one of the applications using umbrella. So when user press the icon, so users can feel the recorded rain like this.
Oh.
And we drop many stuff like baby ballets and toy snakes on the umbrella. So users can feel many kinds of rain.
Raining rubber snakes.
Unusual rain.
Only in Japan.
And this is also a funny project. I don't have good video. This is an interview video. Paranga is a book-shaped device that gives us tactile sensations of turning pages. So when that is me. So when user bend the book-shaped device, so motor rotate and gives the sensations of turning page. This is the application of flipbook.
This is a joint project too.
Sorry?
So this is a joint project, yeah?
Joint.
Yeah, so I think some of
Yes.
some of my students work on this.
Yes. So we will present this on SIGGRAPH Asia with the member of the previous member of the WPI. Okay, let me move on to today's topic. The title is Ambient Suite, Enhancing Communication Among Multiple Participants. At first, I will show you a video of our system. Ambient Suite is a room-shaped information environment that enhances our communication. in this system, there are various types of sensors and displays that surround the participants. And the displays cooperatively work to activate conversation. There are many displays and activate conversation. Let me talk about the background of this study. Communication is, of course, an essential factor in our life. So there are many researches for the better communication in various research areas. In the field of social psychology, researchers have tried to analyze conversations. It is to find how conversations are influenced by verbal or nonverbal cues. Nonverbal cues means utterances, body movements, and facial expressions, etc. There are a lot of studies to estimate the states of conversation from these cues detected by sensors. Because of these research efforts, the roles of the cues are being revealed. Mainly in computer science, researchers have explored communication support systems that present information to participants for various situations. Meeting mediator visualized the balance and the interactivity of conversation on participants' phone to make them improve their social behaviors. Proactive display shows keyword or relevant image to all of people in front of the display using personal information extracted from RFID tags. These systems are reported to lead to participants' satisfaction in their user studies. However, most of them offer people to see information in a fixed way on a fixed screen. So they cannot present rich information like person-specific information. This also leads that the system limits the situation and the place and the number of participants. So in this study, we propose a novel room-shaped information environment called Ambient Suite. One of its main features is that all sensors and displays surround the participants in the room, and they cooperatively work to activate conversation. This study is the proposal of a kind of framework, so it can be applied to a wide range of situations, such as brainstorming and drinking parties, and standing parties, like that, something like that. But this time, we implemented an application for a standing party situation to test its capability. The reason of this choice is that it is one of the most difficult situations for sensing the position of people, because they can walk around freely. This is a basic system flow of Ambient Suite that consists of sensing, modeling, and displaying. In sensing, sensors track participants' various nonverbal behaviors. Using them, the system estimates the states of conversation, such as how active or how balanced or who the reader is, something like that. Based on the estimated states, the display presents various types of information to stimulate conversation. I'm going to show you the detail for each process in the case of our standing party implementation. For sensing, participants are asked to have some sensors and markers. As you can see in the picture, we developed a cup-shaped device equipped with a microphone and accelerometer to fit party situations. This is actually a cup with iPod Touch. This device can measure participants' utterance and hand movements without wearing it. Participants also wear another wireless accelerometers to recognize their hand gestures and a marker of 3D position sensors. All the data extracted by the sensor are sent to server PC. To estimate the conversation states, we apply multi-regression model of conversation activity. In this model, an activity of a conversation is represented as a linear sum of speaking time, head rotation frequency, and hand acceleration. As a first step of the implementation, we decided to use these coefficients as a reference. Display environment is the main feature of this system. In our implementation, there are 3 different types of displays which can cooperatively work. There are 2 wall displays on 2 sides of the room for showing public information. A short focus projector is used for 130-inch screen for each. The floor is also used as a display. It is useful for showing information depending on position of people. 2 short projectors from 2 opposite sides project to the same area to avoid occluding the participant's feet. To present private information to specific participant, we used a cup-shaped device. We can switch these 3 types of displays. One of most important issues is what kind of information we should present to people. The aims of information are to increase and balance conversations and to make people friendly. Based on existing works, we introduced 2 types of information, which are activity info and interest info. These are examples of combination between the wall and floor display. I'm going to explain them. In the activity info, displays show the participants' conversation activity calculated at every 10 seconds. On the wall displays, the transition of the conversation activity is illustrated in the line graph. On the floor, the activity for each participant is visualized like a heat map. With this visualization, we expect that participants observe their activity and try to keep it high. In the interest info, we present information about their common interest. In advance, we gather which topics participants are interested in. It can be their hobbies, club activities, or news, like that. On the wall display, a picture about a specific interest is shown. At the same time, floor display highlights the person who have interests about it to make it easy to share their interests. We experimentally evaluated Ambient Suite with a real conversation, assuming a standing party situation. One of the purposes of the experiment was to test the performance of room-shaped system. It means it includes to confirm whether our proposed system got adequately sensor data and whether the collaborative information presentation worked well. Another purpose was to compare two types of the information. 101 people participated in the experiment. All participants were Japanese graduate or undergraduate students whose ages averaged 21.7. We made 17 groups consist of six persons. It has 3 males and 3 females who had never met each other before the experiment. Here is the experimental design. Before the experiment, the participants were asked to fill the preliminary questionnaire. After that, they put on the sensors and the name tags, and they were given a cup of tea in the cup-shaped device. The participants had 2 12-minute conversations set for 12 minutes conversation sets for with and without information presentation condition. We fixed the order of the condition of information presentation. The first was with, without information, and the second was with. In the with information condition, participants had 6 minutes for each activity info and interest info. The order of the 2 information was counterbalanced.
Should that be instruction 2 should be without or with?
Without?
So in your diagram.
Yes, without. Sorry. Yes, it should be with information. Okay. During the experiment, participants were allowed to talk freely to become friendly in both of the conditions. Before the second conversation, we explained the meaning of each information to the participants. And they were not forced, but allowed to talk about the displayed information. Before the experiment, we chose 10 items that participants might be interested in based on their club activities. In the preliminary questionnaire, all participants ranked these items. During the experiment, during the conversations, 12 photos about 4 categories, which are highly ranked by many participants, were used for the interesting info. This picture shows examples of them. In post-task questionnaire, we conducted a 5-point scale subjective measurement for each 12 minutes to rate the conversation and presented information. The questions were about how active the conversation was, whether someone led the conversation or not, and whether the participants shared their knowledge or not. With information condition, we asked how much they use each information in their talk. Let me move on the result. Here is the average score of subjective measurement about their conversation. Light gray bar shows without information, and dark gray means with information. And the score, in the score, 1 means disagree, and 5 means agree. As you can see in the graph, conversation felt more active with information than without. On the other hand, participants felt that conversation was less led by someone with information than without. This is a comparison of two types of information. The result shows that interested info was strongly preferred by participants to activity info. From the results of experiment, we found that our information presentation succeeded to activate and balanced conversation. However, further study is required to precisely measure how much the conversation was activated by the information because of fixed order of the condition. Regarding two types of information, interest info was effective for activating conversation. Using this information, participants got to talk about more private topics like hobbies. In addition, periodic change of image kept conversation lively. On the other hand, activity info was used well at the beginning of the talk, but was not more effective than we expected. We think it was because this information was taken as not serious information, but funny information. So this kind of information might be effective where people have to do discussion like group meetings. Our system achieved high accuracy of measurement at all sensors because the room-shaped feature made the system robust. Room-shaped feature also realized the display combination. Actually, participants easily understood and enjoyed the collaborations among the wall and floor displays. Sometimes they did gestures and walked around the room to share the information. These observations suggest that a room-shaped system worked well even where participants' position and direction changed dynamically in the conversation space. This is our conclusion. We proposed Ambient Suite assuming standing party and confirmed that it measures the participants' conversation state and presented various types of information, which led to enhanced and balanced conversations. Our future work at the moment is to improve sensors and displays. Sensors should be less conscious of wearing them. And as for the display, we are going to consider private information presentation using a cup-shaped device. We are also planning to establish an algorithm to switch information based on participant states automatically. Thank you for your attention.